Welcome to Earth Science. In the last video, I had you do the puzzle of which of these games must I have put down first, knowing that I treat my games well and I wouldn't just pick one up and jam another one underneath it. I put them down one at a time, nice and neat, right? So if you looked at that video, and it's, this is a very easy question, I must have put down photosynthesis first, ethno second, dragon castle third, and space fourth. That, though it's a silly example, is one of the things that we've used to try to figure out how old rock layers are, and therefore how old the Earth is. How have we been able to figure out all of this stuff? How can I, as a science teacher, say, hey, all of this is what's going on? Well, it's a combination of rules, and if we were actually in class, what we do on these, and believe it or not, students kind of enjoy it because it's a puzzle you got to figure out, is figure out, well, what must have happened first, second, third, fourth, and so on. Superposition says that the older rocks are down towards the bottom and younger rocks get put on top of that. There's a rule with something cutting across, like this fault right here. This is a crack in the rock, a fault. That couldn't have happened to all of these rock layers unless those rock layers were there. So it shows us that the fault is actually one of the younger events on this thing. How about these igneous intrusions? When did they happen, These other rock layers were here, but maybe these ones, that pink one was, but maybe the orange one was not yet. And by untangling those kinds of puzzles, we've been able to go back and figure out what's going on in Earth's history. This is over in, I believe, Scotland. And this is one of the places where geology was kind of born. There would have been the idea before this that the Earth was reasonably young, that things like this happened because of major catastrophic processes that somehow magically aren't a thing anymore, now that humans are here. We've now unraveled that's not the case. We've figured out that rock formations happen because of really, really, really long amounts of time where very slow processes fill this in. So one of the things that tipped off geologists over here was sedimentary layers at an angle like this and then at an angle like this. Now, anybody that's watched sediment accumulate knows that it happens in horizontal piles. That's a rule too, original horizontality. So a couple things must have happened here, and they got to thinking like, well, if these guys are telling me the Earth is only a couple thousand years old, we don't have a couple thousand years of history here. We've got a really long time worth of history, because we would have had to have had these rock layers as sediment, because they're sedimentary. You go pick at them, there's sediment in them. These would have had to have been deposited flat. Then we would have had some sort of event that would tilt these rocks this way. Then erosion took care of, whoop, don't touch the screen. Then erosion took care of that. Then subsequent deposition happened on top, and in fact a little bit of tilting after this. So this has so many separate events in it that there's no way that the Earth is only a couple thousand years old. So through time, what we've done is take that idea and, as simple as it is with the stacked board games, gone and tried to figure out what's going on with the whole entire history of the Earth. Now, there's nowhere on Earth where there's one section from the very oldest rocks to the very youngest rocks. Excuse me. But what we've been able to do is take a place like Grand Canyon, which I've never been to, but if you've seen pictures, it's got a whole bunch of sedimentary rock layers, pretty easy to interpret. Oldest stuff on bottom, youngest stuff on top. But then if we correlate and say, okay, let's take notes on the fossils and the sediment and whatever we see in this formation and look for it in other places, because there's nothing else on top here. That rock's gone, it's eroded away. And you come over to Zion, another place I've never been, and you can correlate. You can see that those two rocks match, and there's more on top of that. So even though we couldn't see older rocks below that, they're buried. Now we can correlate and say, okay, from here to here, then from here to here, and then from here to here, here to here, and you can get yourself, instead of individual little sections like you might have in the Grand Canyon, now you get a more complete story of what's going on through Earth's history. And by hundreds of years, I won't say millions of geologists, but the better part of it, many, many, many people doing many hours of work and building on each other's experience and taking the, kicking the stone further down the road each time, building on our knowledge, we've been able to put together a pretty thorough version of what must have happened throughout Earth's history. Okay, so there's two things though. That's going to be relative dating. That all this really does is say, hey, that one is older than that one, and therefore all the rocks here at the Grand Canyon are older than this set of rocks up here at Zion. How did we come to get these numbers? That's going to be another story for another video, probably next week at this point. But there's our first technique, which is called relative dating. Which one's older or younger relative to another one. That'll do it for now. Hope you guys are doing okay. We're almost there. Take care. We'll talk to you soon. Where did I go? Okay. Welcome to Air Science.